We would like to find a such that f of x, given here as ax plus 3 when x is greater than 1, and 5x squared minus 3 when x is less than or equal to 1, is continuous at x equals 1. So what does it mean to be continuous at x equals 1? Remember that continuous means we want to check for three things. Does f of 1 exist? 2, does the limit as x goes to 1 of f of x exist? And this means we want to check the limit as x goes to 1 from the left of f of x and see if it equals the limit as x goes to 1 from the right of f of x. And then step 3, does the limit as x goes to 1 of f of x equal f of 1? So these are the things we want to check. So if we look at number 1, does f of 1 exist? Well, 1 is defined in the bottom function. So f of 1 is 5 times 1 squared minus 3. We know this because of this little underline symbol, x less than or equal to 1. And so we get f of 1 is 2. Step 2 here, does the limit exist? Well, since it's a piecewise function, we have to take the limit from the left and the right separately, because numbers bigger than 1 get plugged into a different part of the function than numbers smaller than 1. So let's look at the limit as x approaches 1 from the left of f of x. And now we want to make sure we show which function we're using. So this is the limit as x goes to 1 from the left of, where do we put numbers less than 1? We put them here. So 5x squared minus 3. Now that's a continuous function. So we know right away that we can just plug in now and we get 2. The limit as x goes to 1 from the right of f of x is the limit as x goes to 1 from the right. Now we use the top function because that's where we put numbers bigger than 1. So ax plus 3. And this is also a continuous function. So we can just plug in the 1 and we get a plus 3. Now we need these two limits to be equal to one another in order to have a continuous function, in order for the limit to even exist. So we are going to say we need 2 to equal a plus 3, but that means a has to be negative 1. And if a is negative 1, then we will have that these two limits equal one another. And we will also have that f of 1 equals 2 equals the limit as x goes to 1 of f of x. So it will be continuous at x equals 1 when a is negative 1.